দিদির এনে কাজ করছে না। Today we will discuss about characteristics of good bricks. You can see here, these are taken from engineering materials of Aziz. Brick should be uniform in color and size. They should be sound and compact. They should be free from cracks and other flaws such as air bubble, stone nodules. These are the characteristics of good bricks. So they should not absorb more than 1/6 of their own weight of water when immersed in water for 24 hours. Similarly, compressive strength will be 5,000 to 8,000 psi, and soluble salt will be not more than 2.5%. Also, they should neither overburnt nor underburnt. We have discussed earlier overburnt and underburnt bricks characteristics. These are not good for construction. So, I think you have seen these characteristics. These are the good characteristics of good brick. So, how we can assess a good brick? There are various tests, field test and laboratory test. You know, laboratory test, we can do size and shape, unit weight, water absorption, salinity test, soundness test or resistance to weathering, compressive strength test. We have to do for characterization of bricks this laboratory test. So bricks are stocked in the field. Initially you can see the field test. There are 4 types of field test: nail test, sound test, t-test and color test. So laboratory test, I think you have done in the laboratory for bricks. So I can discuss if any confusion with you. Any confusion? Hello?
No, sir.
Thanks. Earlier, I think we have completed this portion, bricks. Earlier means in the offline classes before lockdown.
Yes, sir.
We have completed these topics, I think.
Yes, sir.
Okay, whatever it is. So that's why I think field test you have idea, because I have discussed in that class. Nail test. What about nail test? Taking a brick, a scratch by nail, trying to scratch on the brick surface. If it gives a what can I say? Gives a stress, then it is not a good brick. Similarly, sound test. It gives a metallic sound, then it is good brick. T-test, I told you, I think, making a T by 2 bricks and uh, free fall from 6 feet height. After falling, if these are not break, then these are good break. Color test, color, it may not be a field test, but color is one of the good significance, because color should not be yellow color. Yellow color means these are underburned brick. It should be uh, reddish black color, something like. Then it will be good. Okay, so you know about standard size of brick. I have written here, you can see in the screen, 9.5 inch, 4.5 inch, 2.75, according to PWD of Bangladesh. PWD, full name? Anybody?
Public Works Department.
Yes. So why this one, this size has been standardized? Can you tell me? Anybody?
Because of the wall thickness in our countries.
Yes. 10 inch, 5 inch, 15 inch. So that's why with mortar, this become 9.5 inch becomes 10 inch. With mortar, 4.5 inch become 5 inch. That's why this is the standard size, have been standardized by PWD. So a classification, I think these are also I have discussed with you. First class brick, second class brick, third class brick, overburnt or underburnt brick. Last class you did not say me, these are already been discussed in the offline class before. So I have reviewed, I think, whatever it is. So we are completing the brick chapter. The first class brick properties I have shown here, you can see. The properties you can see from Aziz book. Second class brick properties, third class brick generally underburned. So these are the properties you have to know, because you are a civil engineer. Always you have to do work with bricks, cement, rod. So this should be clear to you. So uses of brick, this one also I have completed. Construction of wall, construction of floors, construction of arches and cornices, making kwa. Kwa means broken brick, manufacture of shurki. A special brick, I have written here 6 types of special brick: perforated bricks, hollow bricks, checkered bricks, clinker, flint bricks, gem bricks. Here some pictures I have shown here. These are taken from books of Aziz. So okay, we will discuss today another chapter. So you can wait for 1 minute. Can you see this picture?
No, sir.
Yes, sir.
Cement.
Yes, sir.
Ah, we are going for start a new chapter. This is cement. Cement is the most important material for civil engineering construction. Without cement, one material cannot be bind with another material. We are binding aggregate sand through cement only. But without water, it will not bind themselves. So water is also essential for binding them. Okay, somebody can start after passing UG cement factory. I think you know there are lot of cement factories in Bangladesh. So anybody can tell 5 of them? Hello?
जी सर, एलिफेंट सीमेंट,
Okay.
रॉयल सीमेंट,
Yes.
Shah cement.
Shah cement. Good.
Diamond cement.
Diamond cement.
Tiger cement.
Tiger.
Bosundhara.
सुंदरा सीमेंट,
Crown
Ah.
cement.
Premier
Wholesale
cement.
cement.
Seven
Okay.
ring cement. Five ring
Okay.
cement.
Oh, confidence
Bosundhara
cement. Yeah, wholesale. Very good. You know, I think because
Aki cement.
Aki cement.
Shah cement.
Okay. Acha, let us start what is cement. Cement is a greenish gray colored powder made of calcined mixture of clay and limestone. When mixed with water, becomes a hard and strong building material. Without water, cement cannot react with, cannot bind other material. Water and cement, by giving reaction, inert material are binding. So cement is very essential for making any structure, civil engineering structure. So popular as binding material. Material with adhesive and cohesive properties. You know about adhesive and cohesive. To bind the fine and coarse aggregate together. To fill void in between fine and coarse aggregate particle form a compact mass. These are the characteristics of cement. So you cannot find these characteristics, I think, in your book. I have taken from some other books. I have taken mainly Shetty's book. Shetty's engineering material is there. You can find it from this book. Natural cement and artificial cement. There are two types of cement. Artificial cement, what we are seeing in the field or market, these are all artificial cement. Earlier, people are using natural cement. It has been natural cement first obtained from argillaceous limestone in England. By whom? You have seen by whom?
Joseph Parker.
Joseph Parker. So I think before lockdown we have discussed these things. Cement we have started earlier. No. Oh, nobody knows. Okay. Already we have started earlier.
স্যার পুরো হয়েছিল স্যার, মানে এতটুকুই স্যার হয়েছিল।
গ্রিক পর্যন্ত
রোমানরা স্যার প্রথম সিমেন্ট ইউজ করতো।
রোমান প্রথম সিমেন্ট ইউজ করতে ঠিক আছে, কিন্তু ফার্স্ট obtained from argillaceous limestone. Have you any idea about argillaceous limestone? No. These are the naturally found stone. Joseph Parker first obtained from this stone in England. Okay, it's enough. But nowadays all are artificial cement. So how we can manufacture artificial cement, and what are the properties of cement, we will discuss in this chapter. Okay, artificial cement is manufactured by burning appropriately proportioned mixture of calcareous and argillaceous material at a high temperature, and then grinding the resulting burned mixtures to a fine powder. এক কথায় এখানে বলে দেয়া আছে কিভাবে আমরা আর্টিফিশিয়াল সিমেন্ট তৈরি করি। তাহলে দুইটা স্টোন লাগবে, দুইটা ম্যাটেরিয়াল লাগবে। কি কি? একটা ক্যালকারিয়াস আর একটা আর্জিলেসিয়াস। These two proportionate mixture 1:3 at a high temperature, then grinding. Okay, this burn mixture of calcareous and argillaceous matter is known as clinker. Argillaceous and calcareous matter একটা প্রপোর্শনাল মিক্সারে মিক্স করে একটা প্রসেসে আনতে হয়, ওখান থেকে হাই টেম্পারেচারে যে ম্যাটেরিয়াল উৎপন্ন হয় তার নাম হচ্ছে ক্লিংকার। তাহলে cement is a binding material. Lime is also a binding material. So which one is better? Cement is better for following conditions and requirements. That's why sometimes it may be a question, which one is superior? Cement will be superior. And why? Because for construction of a structure in wet places, ভিজা প্লেসে এগুলো কনস্ট্রাকশন করা যায়, লাইম তেমন করা যায় না। And under water, where great strength and durability of structures are required, where mortar or plaster has to set quick and attain its strength. Similarly, there are another 3 points. These are taken from books of Aziz. You can see there. I think everybody has Aziz book, so you can see there. Now, ordinary Portland cement. Ordinary Portland cement is this cement generally not found in the market now. Earlier it was very available. After 2000, that means before 2008, these are very available. After 2000, people are very clever, mainly manufacturer. They mix some low-cost material like fly ash, slag, something this worst material, but these are having some binding properties. That's why they are mixing with ordinary Portland cement by some percentage. Somebody are mixing 15%, 20%, something like this. That's why nowadays this cement is known as composite cement, not ordinary Portland cement. If you see a bag of cement, you can see these are composite cement. There will be written on the bag. So whatever it is, ordinary Portland cement, we are discussing about ordinary Portland cement. With this, if we 15 to 20% fly ash or slag material added, then it becomes composite cement. Understand? Hello?
Yes, sir.
Yes, sir.
Okay. So, what is composite cement? Anybody? Huh? Nobody. Composite cement means mixture of ordinary Portland cement and other inert, something like inert material, slag or fly ash. These are industrial waste material, but these are granular material. These are added to a percentage of about 15 to 20% in the industry itself. So that's why these are known as composite cement. Ordinary Portland cement is now a rare material. Rare materials you can get by ordering to manufacturer. Suppose you need ordinary Portland cement of 50 bags, then what you have to do? You have to order to manufacturer. I need 500 or 50 bags of ordinary Portland cement, please supply. Then they will they will manufacture, but cost will be somewhat higher than composite cement. Okay. What are the composition of ordinary Portland cement? You can see here there are two raw materials. I told earlier, one is calcareous material, another is argillaceous material. Calcareous material is the mainly compounds of calcium and magnesium. Limestone are the common calcareous material. Limestone, calcium and magnesium are the main component of this calcareous material. Argillaceous will be clay, shell, iron, etc. That means there are some silica, alumina and oxides of iron. That means clay and shell are the common argillaceous material. I think you understand these two raw material. So for preparing ordinary Portland cement, there needs two component. One is calcareous material, another is argillaceous material. Now, constituents of Portland cement. Mineral constituents. Mainly 4 mineral constituents. I have shown here these 4 main components. C3A. You can see here, these are mineral components. Main 4 components of Portland cement. These are the chemical composition. 3CaO, calcium oxide, silicon dioxide. Similarly, 3 alumina, 3 calcium oxide, 1 alumina, 4 calcium oxide, alumina and ferric oxide. That's why abbreviated name tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetra calcium sulfate will be added after making clinker. It depends on the nature of tricalcium aluminate. Tricalcium aluminate. How much percentage I have to add? This will depend the percentage of tricalcium aluminate. That means C3A. This is tricalcium aluminate. This is important factor. So I think we have understood the mineral constituents. Now, acid and alkaline constituents. Acid and alkaline constituents, these are the mainly chemical composition of raw material. These are known as acid and alkaline constituents. And this is mineral constituents. These are chemical composition of clinker, mainly clinker. So don't confuse with mineral constituents with acid and alkaline constituents. Acid and alkaline constituents, these are all oxides of some metal. You can see here calcium oxide, magnesium oxide, silicon oxide, aluminum oxide, ferric oxide, sulfur trioxide, potassium oxide, sodium oxide. These are the main component of raw material. These are known as acid and alkaline constituents. And what are the ranges? Approximate ranges is there. While manufacturing cement, your proportion will be within this limit. Otherwise, the cement will not be good. That's why lot of cement brand are available in Bangladesh. So all are not same quality. We are regularly testing the various types of cement companies, cement bag. So we are we found all the cement are not good. So one good cement, I think we can say confidence cement, wholesome cement. Similarly, lot of good cement is there, but all cement are not good. Okay, what are the functions of these acid and alkaline constituents? Here you can see lime, calcium oxide, about 63%. What are the functions? What are the, if it is sufficient, then it will give you the good result. If it is less, it will hamper your property of the cement. If it is more, it also hampers the quality of cement. That's why I have written here, these are taken from book, Aziz book. That's why I told you earlier in the offline class also, Aziz book is the main textbook. Similarly, silica 17 to 25%, alumina 3 to 8%. Here we have written, I have to read these things. Hello, can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
So, okay. Then These are the magnesia, iron oxide, calcium sulfate, sulfur trioxide, alkalis. These are the main component. I think we have to stop here because your time is over.